All right, so let's look at our first question here. Deliberately, ngiqale ngequestion lene graph ngoba ngiyathi ma graph anokunibhamula. So I decided because ngiqale ngequestion lene graph sizame khona understand the question lene graph. So if you find a question like this, and here this is a velocity time graph, okay? We need to firstly analyze the graph. I'm not even going to read the statement first. I'm just going to analyze the graph. There are three phases in the graph, okay? There's the initial velocity when the object starts moving. So the object starts moving here. Let me just put that. It starts moving here at this point. Why is this thing not writing here? So I'm going to put the red color. So it starts moving here, okay? It starts moving with an initial velocity which is equals to 8 meters per second and it's going in the eastward direction. So the initial velocity is equals to 8 meters per second east. Are we okay? Now, what is happening from this point up until this point? The velocity is changing, okay? So this is during, we can call this the time of contact. It's the time when the two objects were in contact here, okay? From here up until here. And what is happening in this line? That is the final velocity of the object, which means now that the final velocity of object, which is VF, is equals to 4 meters per second. Okay, let me explain again. Starting point, contact or during the collision, and then this is after. Before, during, after. Before, which is this, during is this, and after is that. Okay, so the initial velocity of the object is 8, the final velocity is 4. No, I hope sonke sayivisisa lento sigrand sharp simjojo. Now, let's go to the statement. So, trolley X of mass 1.2 kg travels at an initial velocity of 8 meters per second. We've already said that it's going to the eastward direction. It collides with trolley Y of mass 0.5 kg, which is initially at rest. So, trolley Y is initially at rest. So it's not moving initial. What does it mean about trolley Y? The initial velocity of Y is equals to 0. Okay, let's do this now. Let's put this data into perspective. So let's write our data. It's very important in physical sciences that you write the data. So we have what? Trolley X. Okay, what did they say about trolley X? The mass of trolley X is equals to 1.2 kilogram. We've established that the initial velocity is 8 meters per second and is going in the eastward direction. And we also know that the final velocity of trolley X is 4 meters per second east. Okay, what do we know about trolley Y? Trolley Y, we know that the mass of trolley Y is equals to 0.5 kilograms, and we know that the initial velocity of trolley Y is equals to 0. So this is the information that we currently have, okay? Now let's go to our question here. Question number 4.1, it says we must state the principle of conservation of linear momentum. So this is the principle that states that in an isolated system, the total linear momentum is conserved. So in an isolated system, the total linear momentum is conserved. Okay, so that's basically what is meant by that. So in an isolated system, the total linear momentum is conserved, or it remains constant. Okay, so that's what is meant by that. Number 2, it says calculate the magnitude of the velocity of Y immediately after the collision. How do we calculate that? Let's go to where we have our data. and try to debunk that. Okay, let's go to where we have our data and try to calculate that. So what do we do now? We can say that the sum, we're using the principle of the momentum before, is exactly equals to the sum of the momentum after. Okay, so the sum of the momentum before, it will be the momentum of trolley X before plus the momentum of trolley Y before. This will be equals to the momentum of trolley X after the collision plus the momentum of trolley Y after the collision. Okay, so we are saying the sum of these two before must be equals to the sum of these two after. Let's look, what is the momentum? How do we calculate momentum? For trolley X, it will be the mass of the trolley X before, and then the velocity, which is the initial velocity of trolley X, plus the mass of trolley Y before, as well as the initial velocity of trolley Y before the collision. This is equals to the mass of X after the collision, the velocity of X after the collision, plus the mass of Y after the collision, as well as the velocity of Y after the collision. Now let's put things together. Now it's simple to substitute because we've already written down our data. So let's see how we substitute. Okay, what is the mass of X? It's 1,2. What is the velocity of X just before the collision? Is 8. Plus, what is the mass of Y? 0,5. What is the initial velocity of Y? It's equals to 0. Now, this is equals to, we look at the after situation. What happens after the collision? We know that for trolley X, the mass will still remain at 1,2, but the velocity now changes to what? To 4, okay? This is plus the mass of the trolley again, which is 0,5, as well as the velocity of the trolley, which we are looking for, okay? These two will give us 0, which means now here we're going to have 9,6, which is equals to 4,8 plus 0,5 VF. Now, what this, you can just simplify and calculate the final velocity of this object. Please go through the steps, try to understand what went through. But if you go through this and you repeat it several times, this should be a basic question where all of us collect the marks there. All right. We will then look at the other questions